Hello. In this February 2026 podcast, I'm hoping to demonstrate that the expanding universe and the Big Bang Theory are not only false, but probably have been known to be false for some time. The vacuum energy described by quantum mechanics is a notion conjured up from the uncertainty principle. On the face of it, it sounds like a contradiction in terms, as a vacuum is defined as a space entirely devoid of matter. It is argued by the particle physicists that there cannot be a vacuum with no particle in it because it would contradict the uncertainty principle, expressed generally as the uncertainty in position times the uncertainty in momentum is equal or greater than h bar, that's Planck's constant for angular motion, divided by 2. The uncertainty principle requires that at every point in space, the lowest energy density must conform to this equation. Quantum field theory relies on this analysis to support its picture of quantum fields as fluctuations of energy, which can be analysed as different categories of particles. In a vacuum, this causes the creation of virtual particles or fluctuations, which contribute briefly to the energy density of the vacuum. The uncertainty principle is the cornerstone of the belief in vacuum energy, or zero-point fluctuations, or zero-point energy, ZPE, or dark energy, which in turn supports the expanding universe and the Big Bang Theory. The theoretical value of the vacuum energy, or energy density of the vacuum, is 10 to the power 112 ergs per cubic centimetre, and 1000 ergs equals 1 joule. This is a huge amount of energy, and given the measured experimental value is close to 0, indicates how shaky are the foundations on which quantum field theory is built. This huge disparity is referred to as the vacuum energy catastrophe. I dealt with the invalidity of the uncertainty principle in earlier podcasts, but broadly, if it is assumed that electrons and photons are point particles obeying conservation laws for energy and momentum, then the classical deterministic framework applies and there is no uncertainty. Moving along to the cosmological constant, which was introduced by Einstein to counter the effects of gravity in his static and finite universe. This was appropriated and used to represent vacuum energy, which was linked to dark energy, etc., and supported the model of an expanding universe and the Big Bang Theory. I believe scientists are still arguing about the value of the cosmological constant. Notwithstanding this and the endless changes of nomenclature, the prevailing orthodoxy is that this theoretical result is supported by the Casimir effect and the Lamb shift. As demonstrated in essays on my website, experiments have been misinterpreted frequently to provide support for questionable theories, for example, Compton's scattering and Bell's inequalities. In a paper by R.I. Jaffe, that's Jaffe, entitled The Casimir Effect and the Quantum Vacuum, it is argued that the Casimir effect is not conclusive proof of the existence of vacuum energy. Quote, Casimir physics has become an active area of nanoscopic physics in its own right. Not surprisingly, every review and text on the subject highlights the supposed special connection between the Casimir effect and the vacuum fluctuations of the electromagnetic field. The object of this paper is to point out that the Casimir effect gives no more or less support for the reality of the vacuum energy of fluctuating quantum fields than any other one-loop effect in quantum electrodynamics. The Casimir force can be calculated without reference to vacuum fluctuations, and like all other observable effects in QED, it vanishes as the fine structure constant A goes to 0. This is from the Massachusetts Institute of Technology, dated March 2005. I cannot judge if this is correct or not, but I'm simply drawing attention to the fact that doubts from MIT seem to have been swept aside in the promotion of the existence of vacuum energy. The other pillar supporting the expanding universe and Big Bang model is the red shift discovered by Hubble in around 1929. It can be interpreted as galaxies receding, not necessarily because of their motion per se as in the Doppler effect of sound waves, but because of the expansion of space itself. Einstein, not being an astrophysicist, accepted the arguments from the Dutch astrophysicist Sitter and others on these matters, and that is what led him to believe that his introduction of the cosmological constant to preserve a static universe was his greatest blunder. Einstein did nevertheless have reservations, especially as the measured red shift conflicted with other astronomical data. Quote, "There does arise, however, a strange difficulty. The interpretation of the galactic line shift discovered by Hubble as an expansion, which can hardly be doubted from a theoretical point of view, leads to an origin of this expansion which lies only about 10 to the power 9 years ago, while physical astronomy makes it appear that the development of 15 individual stars and systems of stars takes considerably longer. It is in no way known how this incongruity is to be overcome." Close quote. I believe this problem persists despite improved measuring techniques. But Einstein was not alone in questioning the conclusions drawn from the redshift observations. Hubble himself had never really got on board and questioned its validity on a number of grounds. For example, could it be explained by the light waves losing energy and therefore frequency along their epic journey? In his book, The Observational Approach to Cosmology, Hubble wrote, quote, "If redshifts are produced in the nebulae where the light originates, they are probably the familiar velocity shifts, and they measure an expansion of the universe. If the nebulae are not rapidly receding, redshifts are probably introduced between the nebulae and the observer. They represent some unknown reaction between the light and the medium through which it travels. The assumption of motion, on the other hand, led to a non-linear law of redshifts, according to which the velocities of recession accelerate with distance or with time counted backwards into the past. A universe that has been expanding in this manner would be so extraordinarily young, the time interval since the expansion began would be so brief that suspicions are at once aroused concerning either the interpretation of redshifts as velocity shifts or the cosmological theory in its present form." Close quote. So Hubble's preliminary conclusions coming from observations was clearly against the interpretation that the redshifts are due to the radial motion of the nebulae away from the Earth. He analyzes a number of parameters, time, energy, and the limitations of the telescope, and arrives at a coefficient and concludes in his book, The Realm of the Nebulae, quote, "The observed coefficient is smaller here than that in the relation calculated on either interpretation of redshifts, but is much closer to the coefficient representing no motion. Careful examination of possible sources of uncertainty suggests that observations can probably be accounted for if redshifts are not velocity shifts. If redshifts are velocity shifts, then some vital factors must have been neglected in the investigation." Close quote. Hubble compares the two conflicting models, the expanding universe and the static universe, and finds in favour of the latter. Quote, "Nevertheless, the ever-expanding model of the first kind seems rather dubious. It cannot be ruled out by observations, but it suggests a forced interpretation of the data. On the other hand, if the recession factor is dropped, if redshifts are not primarily velocity shifts, the picture is simple and plausible." Close quote. So the current orthodoxy rests on shaky foundations, yet is portrayed as inalienable truth and any dissent dismissed. As an example of this, a US astrophysicist, Halton Arp, 1927 to 2013, was banned from using I think it was the Palomar telescope at the Californian Institute of Technology for questioning the prevailing expanding universe theory. He then left the US to work in Germany. Arp had discovered from photographs and spectra that many pairs of quasars, which have extremely high redshift Z values and are therefore thought to be receding from us very rapidly, and thus must be located at a great distance from us, are physically connected to galaxies that have low redshift and are known to be relatively close by. Because of Arp's observations, the assumptions that high redshift objects have to be very far away, on which the Big Bang theory and all of the accepted cosmology is based, should have been fundamentally re-examined years ago. So what does this all add up to? If the uncertainty principle is considered redundant, then there's no vacuum energy catastrophe. And if the interpretation of the red shift as being related to velocity or acceleration is incorrect, then the universe is not expanding and there was no Big Bang. There is an excellent discussion of the Big Bang theory on the Institute for Arts and Ideas website between Eric Lerner, Julian Barber, and Claudia Mariston, dated December 2022. Mariston provides the orthodox view, Eric Lerner refutes this, and Julian Barber considers the so-called expansion can be explained as the universe changing its shape. I've noted the link to this discussion in the notes to this podcast. Please also check out my website at quantumid.science for monthly newsletters. I hope you can join me for my next podcast in March, entitled Why Intelligence is Non-Computable.